upgraded the sheets, upgraded the spreadsheet. I'm going to put the results from exam 3 on the board. Then at the end of the class, I'll give the results. Generally, I'll say that the performance was very good. It was very good as compared to exam 1 and exam 2. So I'll say well done to everyone. And we are looking up to the finals, right? So the finals, that will be cumulative. So when it's getting there, we'll talk more about the finals. But in general, I'll say the performance was very good. We are having some little technical issues, so let's wait for maybe like some 2 minutes. Yeah, you know, but you still have to wait. No, what are you saying that? Oh, I missed the possible. Yeah. Of course, so we started with Monday before we wrote the exam. 5.1, we started talking about normal distributions, and we said that for a normal distribution, we represent it using what? N for the normal, and mean, and what? The standard deviation. Whereby we said the mean is where the distribution is centered at. And the standard deviation is considered so we said normally we represent the normal distribution using the mean and its what? Standard deviation. And the mean is where the distribution is centered at, and the standard deviation is the spread of the distribution. we said that considering the normal distribution and looking at all the distributions that we've looked at, we've talked about the randomization distribution, the sampling distribution, the bootstrap distribution. And there's one thing in common with them, right? You realize that all the distributions are what? Bell-shaped distributions or symmetric distribution. So this leads us to what? Looking at the normal distribution. So all these is a form of recap from Monday. So that is how we represent the normal distribution, the symmetric and the bell-shaped distribution. So we said, based on Monday, as I said, this is a form of recap. We said that the normal distribution is centered around its mean. So looking at the various diagrams that we have, you realize that for the first diagram, it has what? Different means. Looking at the first normal distribution, it's centered at 0, and it has a spread of what? 1. So the 1 here corresponds to its standard deviation. Now looking at the second diagram, it's centered at 2, and its spread is what? Also 1. So you realize that the two normal distributions that we have here, they both have what? Similar spread or similar shape. This is because they all have what? The same standard deviations. That is why they all have the same shape. Now looking at the second diagram, you realize that they both have a common mean. That is where the distribution is centered at. So they have a mean of 0, but you realize that their shapes differ. The shapes differ because they have what? Different standard deviations. So you realize that in the first diagram, or in the first normal curve, we have the mean to be what? 0, and the standard deviation to be 0.5. So that has what? A narrow spread, as compared to the second normal distribution with mean 0 and the spread of 1, or the standard deviation of 1. That has a much wider spread, but the last one has a very wide spread because its mean is what? Is 2. So we looked at all these on Monday. As I said, this is a form of recap because there's been some break after the exam. So it says that if a randomization distribution is normally distributed, you can write it as anyone to help us. How can we write it? Nicholas? A. Why do you think A?
Randomization distribution is centered on one opposites
Thank you. So you realize that if we are comparing the randomization distribution to the normal distribution, as we saw in chapter 4, we said that the randomization distribution is centered around the null, right? The randomization distribution is centered around the null value. So in this case, looking at the various possible answers that we have, A corresponds to what? The right answer. Because if we are looking at a randomization distribution in terms of a normal distribution, then it's centered around the null value, and SE corresponds to the standard error. And this corresponds to what we have here. Centered at the mean, where the standard deviation corresponds to what? The spread of the distribution. So now if we are to apply this same knowledge to this diagram or to this example, you realize that over here, why do we have 0 here? Anyone? Caroline, why do you think we have 0? It's the null value. So you realize that in this case, we are looking at the difference in proportions. So we are looking at the difference in proportions where we can write the null as well. P1 minus P2 is equal to 0. So in that case, that is why we have the distribution centered at 0. That is the null value. This is a randomization distribution. So likewise, looking at the diagram, you can see that the standard deviation is what? 0.056. That is the standard deviation of this distribution. So then, looking at the possible answers, which answer corresponds to the right? Right? B. So you realize that in this case, we have the null because the distribution is centered at 0, and we have what? The standard deviation to be what? 0.056. So the right answer is what? B. So this leads us, or this brings us to what we are talking about, the normal distribution. Now, you realize that in this case, we have what? Different levels for it, but we can draw a smooth curve through it to represent the what? The normal distribution. So now we are going to look at what is this normal distribution. Since all the distributions that we looked at corresponds to what? A symmetric or bell shape. So a normal distribution is always centered at 0, and you have what? The standard error or the standard deviation. So we are looking at this example. It says that mosquitoes were randomized to either eat from a malaria-infected mouse, that is the exposed group, or a healthy mouse, that is the control group. After infection, the parasites go through 2 stages. We have the not yet infectious and the infectious days. So over here, between day 1 to day 8, that is when the mosquitoes are not infected. Then after 9 to 28 days, we consider them to be infected. So over here, the response variable is whether or not the mosquito approached a human being. So before the infectious days, we check whether the mosquitoes approach a human being. And after they become infected, we also look at whether they approach human beings. So in this case, we have what? 2 proportions. We are going to consider 2 proportions in the sense that we have the proportions corresponding to the control group. So the control group will be those when they are not, the control group will correspond to the mosquitoes that were given the not infected parasite. And the exposed group will be the mosquitoes that were given the infected parasite. So after some time, we add or we leave them and see which amongst the mosquitoes approach human beings. So over here we have 2 proportions. So this gives us the what? The null and the alternative hypothesis. So over here we have the less than sign, which corresponds to the fact that less proportion of the mosquitoes approached human beings. So as we saw in chapter 4, always the equal to sign corresponds to the null hypothesis. We always use the equal to sign. Then the alternative, depending on how the question or how the situation is, that will give us a clue as to which sign to use in the alternative. So after some time, we look at what? There are various proportions. Because we have 2 proportions, we are interested in what? The difference in proportions between the 2. So this gives us a difference in proportion of minus 0.131. So that becomes what? The difference in proportions. Over here, we are using what? The side-by-side box here, because we are considering what? A categorical data or a categorical variable. So as we've seen chapter 4, given an observed statistic, we calculate what? The p-value, right? And how do we come by this value? Anyone to help us? How do we get this 0.0097? Anyone?
The values that are extreme or more extreme to the observed statistic, all of them divided by those samples.
Exactly. So over here, to get the p-value, we look at what? The values that are, or the statistics that are extreme or more extreme to the what? Observed statistic. Then we divide that by what? The sample size, right? But in this case, over here, this is what? A randomization distribution. A randomization distribution which has been what? Replaced by a smooth curve. Okay? Because you realize that over here we have the null and the standard error, right? So we have, it says for p-value, we are looking at the p-value from the null and the standard error. And this is telling us that it's what? A randomization distribution. Because it's centered at the null. And this corresponds to what? The standard error. So this is what? Randomization distribution. We are taking the p-value from the randomization distribution, as we've seen in previous chapters. So now, the next thing that we are interested in is we want to represent, or we want to find the standard, we want to find the p-value from the standard normal. We are no longer going to use the randomization distribution. Now we want to find the p-value from the standard normal. So then, because we are finding the p-value from the standard normal, we need to what? Standardize the test statistic. So you realize that when we're finding the p-value from the randomization distribution, we only use the statistic, right? We say that if this is our randomization, so we had the randomization distribution. It's centered at the null value, right? And when we find the p-value, what do? We look at the observed statistic. We look at the observed statistic and consider what? Points that are extreme or more extreme. And that is using the randomization distribution. Now we are switching over to what? The standard normal. So instead of using the randomization distribution, we are now going to use the what? The standard normal, which is centered at 0 and has a standard deviation of 1. Why do you think it's necessary for us to use the standard normal or to standardize this statistic? You realize that when we're using the randomization distribution, some of you were getting different p-values. And I once said that no matter what, the p-value I get and the p-value you get will not change the decision. If I get a p-value of, let's say, 0.003, and someone gets a p-value of 0.005, it will not change the decision as to whether reject or do not reject the null. Now we are standardizing to prevent all these from happening. So when we standardize, we are all going to get a same p-value because we are putting the statistic on a common scale by standardizing. So then this conflicting results or these different answers of the p-value is going to be over, okay? Because we are now standardizing. Standardizing it, we are putting it on a common scale, which implies that we are all going to get the same p-value, okay? So how do we standardize? To standardize, you need your statistic. Then your mean value, you subtract the mean value and divide it by the standard error. Not the standard deviation, by the standard error. So doing that, we standardize this statistic. So it says the standardized test statistic, also known as the Z statistic, is giving us the statistic minus the null divided by the standard error. So in doing this way, we are standardizing the statistic in order for us to get what? A common p-value. So now back to our example that we are looking at. In this case, you realize that this is what? The original statistic that we got when we took what? The difference in proportion. We got this to be what? The original statistic. Now, as we saw, the distribution was centered at what? 0, right? From the randomization distribution. Or if we are writing the null in the alternative, we wrote the null to be right. This was the null, which is the same as writing this as okay. So you realize that from the null hypothesis, we get the distribution, or the null hypothesis is what? Is equal to 0, which means that then it's centered at what? 0, or the null hypothesized value is what? Is 0. So from here, from the general formula of the standardization, we get the statistic minus what? The null value. So take note, it's not always 0. You always need to write your null hypothesis out in order to find out what is the null value. If you don't do it that way, you kind of mess up. So always write out your null hypothesis, then you will know clearly what your null value. It's not always 0. It's 0 in this case because we are looking at what? The difference in proportions. That is why we are having what? 0. Then we divide it by what? The standard error. So this gives us what? Minus 2.34. This value here becomes the what? The standardized test statistic. It's no longer the observed statistic, but instead the standardized test statistic, because we have what? Standardized this original statistic. So now we have to what? Find the p-value. Previously we were using the statistic, we were finding the p-value from what? From the randomization distribution. Now you standardize it, so then you need to find the p-value from the what? From the standard normal. So it says the standard normal distribution is the normal distribution with mean of 0 and a standard deviation of 1. So this is a representation of the standard normal. This distribution is what we are going to use to find the p-value. The previous time where we were using the randomization distribution is over. It's over because now we are standardizing the test statistic. So standardized statistics are compared to what? The standard normal distribution. Comparing it to it will help us come up with the p-value. So over here, you realize that now we've changed this value to correspond to what? The standard, to correspond to the standard normal, the standard test statistic. So in this case, this value here corresponds to the standardized test statistic. Then based on that, we get a p-value. So in doing this, or in doing it in this way, we are all assured of getting one value as our p. We are no longer going to get different values because we are not using the randomization distribution. Realize that the randomization distribution was based on the fact that everything was random. So then we end up getting what? A different p-value. But the difference is not so much. But now we are comparing it to what? The standard normal. So in this case, we need to what? Standardize the test statistic, then compare it to the standard normal to find the p-value. So it's not so much different from what we have been doing. Just that now we've moved a step ahead of finding what? The standard normal. So it says if distribution of statistic is normal, then we compute what? The test statistic. That is the standardized test statistic. Okay. So this is from the original data. As I always said, you need to first find your statistic. And your statistics can be found from what? The sample or from the information that you've been given based on the sample. Then the null value, you get it from what? From H naught. Okay? That is from the null hypothesis, you get your null value. Then from the randomization distribution, you get your standard error. That gives you what? The standardized test statistic. You value to the standard normal to get your p-value. Then you make your decision and your conclusion. So we'll look at some examples of how to do that very soon. So this is some sort of transitioning from this randomization through to what? The standard norm. First, we are using the randomization. You just count the number of points that are extreme or more extreme and divide it by the samples to get a p-value. That is what now we replace this randomization distribution by a smooth curve. You realize that over here we are getting a different what? P-value, right? For the same observed statistic. Now we compare that to what? We standardize the statistic to get a p-value. So in this case, you realize that in all cases we are getting a pretty much close what? P-values. But this helps us to get a general p-value in the sense that our p-values are not going to differ anymore if we use the standard normal. But if we use the randomization distribution, our p-values will differ. It will differ, but it will not differ too much to change the decision. Okay? So now we'll look at some examples then. I have some examples over here for us to work on. So we are looking at the example of firstborn children. It says, are firstborn children actually smarter? We have the explanatory variable to be the firstborn or not. Then the response variable is the combined SAT score. So in this example, we want to find out whether the firstborn is smarter or not based on the SAT score that the child gets. So we have the firstborn, the mean for the firstborn, and we have the mean for not the firstborn. And doing that, we got a difference in mean to be 30.26. So that is what? The difference in means between the SAT score gotten from the firstborn and not the firstborn. Then we have our, based on the randomization distribution, we get the standard error to be 37. So in this example, we want to standardize